Okay, so today I'd like to talk about using Passport.js as the mechanism for authenticating users. If you can read about the details on the Passport.js library by going to passportjs.org. And one of the nice features about Passport.js is that it provides many different what they call strategies, right? Strategies that allow you to consistently be able to interact with third-party authentication authorities like Twitter, Facebook, Google, LinkedIn, all with the same API, right? So that you don't have to deal with the idiosyncrasies of every single API, right? It standardizes the API so that you don't have to deal with them independently. It also provides the normal strategy of, just the common strategy of logging in, which is plain old username and password. Okay, and that's what we're going to introduce today. Just being able to simply log in with a username and password. Okay? And we're going to use Passport.js to be able to protect not only the navigation, right, of what pages can you navigate depending on who you are, right, but also protecting the APIs that allow the client side to be able to talk to the server side in a single page application setup, right? Like we've been looking at in the mean stack. Make sense? All right. So I've provided here several start code that you can use to install and configure Passport.js into your own application. All right. First of all, you'll need to install Passport.js, and you do that from the command line using npm. So it would be npm install passport and -- save. This is going to save the passport as a library dependency for your overall project, right? So that when it gets deployed to Heroku or OpenShift or wherever, right, it gets deployed also on the remote server, right? You also need to install one of several strategies, right? That remember, strategies are different ways that you can authenticate users, either just with plain old username and password, or also third-party authentication authorities. So here's how you install the local strategy, right, which is just username and password. Next week we'll take a look at Google and Facebook. I have already done this for you, right? So your package JSON, right, should already have these two as dependencies. So if you go to package JSON, you'll see that you should have passport, right, and passport local already declared as dependencies for the project. Yes, I've also declared also the passport Google for as a dependency as well. We're going to be using this next week, right, and see how we can log in just with Google. Okay. So make sure that in your dependencies you have those, at least those two listed as dependencies. Okay. Also, once you install those libraries, you need to be able to configure those libraries, right? And to do that, you're going to need to require passport, right? You need to require passport and then declare certain things and configure certain things. One of the things that we're going to be dependent on is two other libraries, right? In particular, the cookie parser library and the express session library. So let me talk about that a little bit. Okay, as you know, HTTP, the HTTP protocol, right, the network communication protocol that we use to communicate between clients and servers and all this communication is considered to be a stateless protocol, right? And what that means is that any one server talking to any one server, any process talking to any one process, right? There is no information in the HTTP communication that uniquely identifies one communication between a client and a server, right? So, for instance, if a server is running and it receives requests from different clients, which is very common, right? You have Wikipedia receiving client requests from any number of browsers, right? The HTTP protocol doesn't have any mechanism that allows the server to distinguish one request from another, right? To know that, oh, it's you again, right? Or it's this other person. As far as the server is concerned, all requests are equal, right? There's no way for it to distinguish to know that it's talking to the same person. Make sense? Right? There is no sense of session, right? Of remembering any discussion, any conversation, and that makes it very inconvenient for certain kinds of applications. Yes. If you every time you need to identify yourself and say, "Hey, it's me again," right? It would be very inconvenient for certain types of applications, right? For many of the original types of applications, this was just fine, right? Especially if you have static pages, that's fine. There's no problem. There's nothing for me to remember about you, any difference from someone else. But there are certain applications that certainly we need to be able to remember who you are, right? If it's a weather application, I would not. Perhaps I'd like to be able to remember that my zip code is 01234. Yes. So that next time around you come, I remember it's still you. I remember your zip code, right? And if someone else comes, right, I'll remember their zip code, and I'll remember that zip code, yes? So that we can enter into conversation, into dialogue, right? And talking to a server application that has no session, it's like talking to someone with Alzheimer's, right? You're talking about something, and then that person just doesn't remember what we're talking about, right? You have to give the context. Somebody else has to keep the context, yes? To maintain that context, there were several mechanisms that were invented. One of them is the cookie. Right? The cookie was invented with the idea of maintaining this context. Yeah? Since the server had no mechanism for remembering, so what the idea was that when you came to a server the very first time, the server says, "Hey, I don't know who you are. Hey, I'll generate a random cookie, right? I'll generate a random piece of string, right? That I will give you, right? So here's the browser, right? And here's the server, okay? And when the browser came, it was expected to provide a unique identifier, right? Which we call a cookie. Right, so part of this communication, I would have provided a cookie. If I don't provide a cookie, the server interprets this as you being the very first time that you come to this website. Okay, and says, okay, I would like to remember you next time around. Right. So whenever the server responded, so here's a request. Request 1, no cookies. Right. The server responded with a random cookie. Right? It could be just a random piece of text, okay? A piece of text that the server, wrote into the database. So it wrote the cookie 123 into the database, right? And the browser, if the browser agreed, right, the browser would store this little cookie in their own database, in their own file system, right? In the browser's cache, okay? So next time around, if the browser came again, right, the next time, the second request, in a second request, it would provide the cookie 123, and the server say, "Oh, it's you again." Right, it's you again. I know you. I remember you. Okay. Any information that I could store, I would store using the cookie as a key. Right. I could go into a database, and any information that I stored, it would be stored against that key. Right. Typically, it would be against the RAM. So in RAM, right, it would have 123 as a key, and there would be an object stored for that cookie. So that if you came, right, if someone else came, I would provide another cookie, right? The first time around, I would provide cookie 234, right? So next time around, right, you provide the same cookie 234, and I would have another object keyed off of that cookie. Make sense? Right? So many APIs were written around this mechanism, and we call this sessions. Right? Session management. Right? Servers were using these cookies, this mechanism, to be able to keep track of people's sessions. So that if you came and you provide me your zip code, I would store that in RAM, or even stored in the database for long-term storage, yes. But as long as I was running, I would just keep it in RAM. Now, up to this point, we haven't done any of that. We haven't been keeping any session information, yes. Instead, we have been writing stateless applications. We have been having the client maintain the session for us. And the way we've done that is by keeping track of the user ID every time you did a request, right? The response also maintained the same user ID. So we always remember who we're talking to, right? But the server itself never had to store anything and remember anything about any one user, yes? All the data was always stored in the database, keyed off of that user ID, and the website ID and the page ID and whatnot, yes? But the server itself never had to remember anything, okay? So we call those stateless applications. Stateless applications tend to be much easier to scale, right? Because the server doesn't have to remember anything. There are very, very small RAM requirements, right? I don't have to remember any of this. Imagine if I had to remember something about you. I would have to maintain something in RAM for you. And then if there's 100 people, I need to remember 100 things, right? 100 sessions going on at the same time. Imagine thousands or tens of thousands, right? That increments the footprint of the need for the requirements for my server. Yes, I need bigger servers, bigger RAM. Maybe it's different CPUs, multi-core, or maybe even have machines in round robin, right, running in tandem. Yes, right. But the less you have to remember, the more stateless your application is, the less footprint that it needs. Makes sense? So it's easier to scale stateless applications, right? It's much harder to scale stateful applications. So we try to maintain that footprint as small as possible. Maybe just remembering the user IDs. That's it. Everything else is stored in the database. I can always fetch it from the database, right? Right. So now the reason we want to maintain statefulness, right, in this particular case, like logging in, right, is that once I log in, perhaps at the beginning there's no session, so I am challenged with the login page, yes, and I identify myself, and so imagine if there was no session, it would be that whenever I go to another page, and again it doesn't know who I am, it would challenge me again to log in. Once I successfully log in, it lets me to that page. When I go to another page, imagine that it would have to challenge me again, right? And then it would let me in. It would be very cumbersome, right? And so instead, we use session to remember, hey, you've logged in already, right? Don't challenge me again, right? It's me, still me, right? And we typically limit these sessions to a particular timeout, right? Typically 30 minutes. Every time you log in, and every time we know that it's still you, we pick up a timer, right? And the timer times out in 30 minutes. We erase the session information and say, oh, I don't know who you are anymore, right? So I would challenge you, right? If you let it time out over 30 minutes. Make sense? So to support this mechanism, we're gonna use these two libraries, the cookie parser and the session library. Okay? Cookie parser, very much like body parser, right? Is going to be able to parse the cookie from the request, right? This cookie that is being sent from the browser is sent over in the headers, right? In the HTTP request headers, right? And out of the box, Node.js doesn't know how to parse this, right? Node.js out of the box, the Express library knows how to parse path parameters, query parameters, but it doesn't know how to parse body, right? The JSON in the body. So we needed to install the body parser, right? Same thing with cookies. It doesn't know how to parse cookies out of the headers, right? So we'll install the cookie parser. Make sense? All right. Now the session library is the library that's going to use that cookie to maintain these objects in RAM, right? Keyed off of those cookies. Right? So it's a library that's going to instantiate these objects, right? These objects are just plain old hash tables. It's just a hash table, right? It's a hash table that is keyed off of that cookie ID, right? And the hash table allows you to put name value pairs. You can store whatever you want in those sections, right? Keyed off of that cookie. right? So that if I log in, I'll have my own hash table. If you log in, you'll have your own hash table, right? Everybody has their own hash table. And you can store whatever you want. You can store a shopping cart, right? You can store your preferences, all sorts of things in that session, right? And the session dies when you restart the server, or if it times out. If you want to be able to remember from from restart or from the next time you log in, you need to store that in the database, right, for long-term storage, right, and recreate the session, right, if you log in next time. Make sense? So session does that. Session manages remembering things across requests. So we need to configure the session, right? So the session object, we need to tell the Express library that to use the session, right? This session will be installing, okay? And we need to configure. One of the things that we need to configure is encrypting the information, encrypting the session, okay? Notice that this cookie over here that's going back and forth, right, between the client and the server, we're going to be storing information that's going to go out of the browser, and it's going to be stored in the client's machine. See that? Right? So whatever we store in there, we got to make sure that that information is not compromised. Right? That could contain some information that might be some private information. It could be the user's email or user's username. Right? Could contain maybe the user ID. Right? Something that uniquely identifies that user. Right? And so we don't want to store it here in clear text because somebody here at the browser could look up all these cookies and see all that information in clear text. Yeah? So we want to make sure that that information goes out to the client is encrypted, right? So that even if they open it, it's gibberish to them. Make sense? But to do that, we can configure a secret. Right? This secret is a random piece of text, right? Whatever you want, doesn't matter, as long as it's the same one. It will be used to encrypt the cookie that goes out, right? And to decrypt it when it comes back from the server. Make sense? Right? Here, I have it in clear text over here, right? But typically, you would instead store it in a environment variable, right? It's stored in your server. You would read that environment variable from the server, right? You wouldn't store it like this because you're going to be putting this in source control, right? And if somebody can see your secret, and then you'd be able to decipher the cookies using that secret. Very unlikely, but it can happen. Once you configure the session, you need to start the cookie parser, right? You configure the cookie parser for the Express library. Then we're going to get Passport initialized, the library initialized, and tell Passport, hey Passport, use the session, right? Which I just initialized, right? I just configured. It needs to be done in this order. First, you configure the base session, right? First, you configure and get this started, and then you start the Passport session. Passport session is going to use this session, right? So if you first have to configure the basic session before getting Passport session get going. Make sense? So it needs to be done in that order. And I believe I've done that for you already. So if you open up your server file, you should have this already configured. Here's Passport, cookie parser, session. Here's us getting the session gets started, right? And here's me suggesting that this should be in an environment variable instead, and getting the cookie parser going and initializing the Passport session. Make sense? All right. Okay. All right. So let's start now using the Passport library to protect some pieces of the application. All right. Yes. Oh yeah. So what it will do is that if it doesn't exist, create a brand new one, right? Otherwise, just use one that's already existing. Right? So what we'll do is that it will ask when the server starts up, saying, is there a session already created, right? if there isn't, automatically create it. Otherwise, you have to programmatically create it yourself. Like this one says, if it's not there, just create it brand new. Yes? So on Windows, so this is how you create the environment variables. So the same way you created the environment variables for logging in to Mongo, right? You created, I assume you did. On Windows, you could use the environment variable preferences, right? In your preferences. No. So yeah, my computer, and then there's an environment variable UI user interface that allows you to create all of the environment, like where you edit path. You know where you edit path? Right there. So you can create any number of these. So you give them names. Here, the name would be session secret, right? And so all those environments, path, all those, right, would be passed to Node.js. We would read them from the operating system, right, and would be available here with proc.env. Okay. On Mac, you would do the bash profile, bash profile off of your home directory. Right? You can open there, you can export different environment variables from there. Okay. I'm not going to open mine because it's got tons of stuff there, which is private, and I'm recording these sessions. So, okay, all right. So let's get started. Let's create a directory here where we can build a little application that does some user management. Okay, we'll write code for logging in and registering just like we did before, right? But we're going to be a little more conscientious and use Passportjs this time around. All right? Yes. Oh yes, you're right. Process. Yep, process. Okay, so let's create a directory here, and where we can play around with Passportjs. So in here, let's see. Let's create an app.js. Let's create a directory where we can work with models, and where we can put services here. So let's create a couple models here that deal with user management. Right. So let's put here user.model.server.js. So here we're going to connect to a database, right? And to do that, we'll just do mongoose var mongoose equal let's see, require mongoose, right? And we'll do a connection string. It'll be something like localhost. What's the? Let me copy from here. Let's see. Okay, so and we'll create we'll create a database specifically for this lecture, right? For doing Passportjs. So we'll do let's see, we'll do webdev 2000 spring 2016 17, and will be Passportjs. Okay, and then we'll connect to that mongoose connects to the connection string. All right, so we got mongoose, and let's create a couple of schema here. We'll say var user schema, and we'll say mongoose dot schema, and we'll have just a username and password, and maybe just a first name. Okay. Also, we'll say that we want the collection to be lectures. This is the morning, and this will be on Passport.js, Passport.js, and this will be user. Okay. We'll create the model, var user model. This will be mongoose model, and the model will be lectures, morning, Passport, JS, user, using the user schema. All right. All right. So let's create a couple. Of users using create user. And here's a user, and this will say user model dot create, and then we provide user, and this will be function error user. So we'll do a console log user to see if the user was created. Very good. And let's do here create user. We'll create a couple of users. One will be username Alice. We'll say password. Oops. And first name. So let's create a few users. So let's create maybe Alice, and Alice. And here we'll create Bob and Bob. And finally we'll create maybe Charlie, ABC. Okay, so let's execute this. See if we can store these folks in the database. We'll go to terminal. We'll go to cd lectures passport models, and we'll do node user model. Okay, it looks like it worked. Let's show DBs, and we just created this one, right? We'll say use that database, show the collections, and that's the collections, right? So we'll say db dot, and then find all the users. Pretty. Oh, there they are. We have Alice, Bob, and Charlie in the database. Everybody good? Okay, we got those three. Let me comment that out. We don't want to create these again. Comment those out. And let's make sure that we can perhaps retrieve them as well. So let's do function find user by credentials. So this will provide maybe the username and password, right? Password. So this will be user model dot find one, and we'll use username as a filter and password as a filter, right? And this will hopefully return just one single user. Yes, and so we'll do console log the actual user. So let's try this out. So we'll say find a user by credentials, and we'll provide Alice and Alice. Yes? So let's run this. No, I didn't mean to do that. We'll run this again from the command line. Oops, we're missing something. Credential. Did I miss something? Oh, it's comma. There we go. So we can retrieve users by username and password. Everybody good? I think we have enough. Let's create a service that uses this. So we'll say this will be user.service.server.js, and so this one will bring. We'll need. Let's see. What do we need? We need app.js. Okay, let's grab app, which is this is the Express library, right? And I've refactored this a little bit so that instead of passing it as an argument, right, you can load it as a singleton. And it's, I think, where did I put it? I think I put it in Express. No, that's not it. Let's go up one more. Express, there it is, Express. So instead of passing it as an argument, right, I can just load it. It's declared only once here in Express, right? It's my own little Express, so it requires it. It creates an instance, right, and it exports it so that I can just load it, right, without you having to pass it to me as an argument. Make sense? All right. All right. So we're going to do a couple things here. We want to be able to log in, right? We want to be able to log in. So let's do that. But when we log in, we want to use Passport as the mechanism for logging in. Right? So we'll need to load Passport. So we'll say var Passport. So we're going to require Passport. Okay. Also, we want to log in using the local strategy, right? Meaning just plain old username and password. Not with Google, not with Facebook, not with Twitter. Just plain old username and password. To do that, we'll need the local strategy. Right? So let's do that. Let's grab the local strategy, and I've given you here some code that you can use to do this. Right? So here it is to load the local strategy. There it is. We loaded it. It's requiring it, and in there you load this strategy, and then there are objects in there. They're singleton objects, right? That you can load that will allow you to configure those strategies, right? So let's configure the strategy. We're going to tell Passport to use that strategy, right? Passport, use that strategy. You can configure several strategies, right? To use not only the local one, but also use Google, also use Facebook, also use Twitter. You can use several different types of strategies at the same time, okay? Right now, we're only going to look at the local strategy, and the way you configure it is that you instantiate a strategy and you pass it as argument a function that will allow you to configure it. Okay? All right, so let's configure it. So we'll create this function strategy, and what this will do is that this function we're going to use it as a mechanism which is going to intercept our communication. Right? Whenever we try to log in, right? If you remember the way we did it for the assignment and previously, we were passing we were trying to find users by credential by passing the username and password, right, as part of a GET request. Remember that? Right? We were passing the username and password in the clear text, right, in a request to the server, right? And so anyone who intercepted that communication could see the username and password in clear text. They could see the request going out as a GET request, right? So that's very not secure at all, right? A much better solution is to send it as a post, right, to the server, right? So that it's not part of the URL, right? But still, even if inside of the post, it's still not secure because it still might be clear text. People could parse the body of the HTTP request, right? So that should be also encrypted. And the way we would encrypt it is to use HTTPS, right? HTTPS. The thing is that the servers that we're using online, the remote servers we're using, Heroku or AWS or OpenShift, right? The free versions that we're all using, they don't support HTTPS, right? If you want to use HTTPS, you have to use one of their paid services, right? You have to pay if you want HTTPS. So I'm not going to require you to use HTTPS for the assignment or for your projects. If you want to play around with it, go ahead and start using one of the paid versions. But it's not a requirement, okay, for you to use the paid. So I'm okay with just using HTTP. Just know, right, that even though you're doing post and the username and password going inside in the body, it's still in the clear text. Yes, unless you use HTTPS, right? All right, so local strategy is going to intercept those posts, right? Whenever we submit the username and password, it's going to intercept that, and it's going to parse the username and password from that post. Okay, and it's going to look up whether that user actually exists or not. Right? If it exists, it's going to add it to the session, saying yes, this is an authenticated user, right? And is the current authenticated user in the session. So anybody who wants to know who the current user is, they can look it up in the session. Okay? Make sense? Right? So we need to do two things. One, we need to configure it, tell it how to find who the user is and password and whatnot from the database. And two, we need to have it intercept our login attempt. Okay? Our login attempt is going to be a post login right here. We're going to say we're going to use app right there, right? That's Express. Is going to be listening for a post. It's going to be listening for a post. API login. I'm going to add a couple more things here. This is lecture mornings morning. So that just to distinguish it with the other section. And there's the login, right? So from the client, we're going to do a post, right? Of passing the username and password. But it's going to be intercepted. So here's our login function, our normal login function, right? That would check the login. But notice that we're putting something in front of it right here. Yes? What we're saying here, hey, there is a separate I want someone else, right, to look at this request before the login. Yes, that was an accent. And that service here is going to use a strategy, the local strategy, right, to see if this username and password are valid or not. Once it gets to the login, our login, right, by that time, that user will either be authenticated, right, or will have been rejected, right, by Passport. Make sense? So by the time it gets to login, we have a valid user, right? If the user doesn't exist, Passport itself will reject the login by sending back an unauthorized error back to the client saying, sorry, this person, I don't know who this person is. So it won't even come to us. We won't even know from the server side, right, whether this person tried to log in because Passport will have shut the door on them and says, nope, this user doesn't exist. Make sense? All right. All right. So this login function will be a very trivial function. Let's break it. Let's bring it. There it is. Here it is. Our login function. It's going to be a very simple function, which we'll put down here, right? By the time it gets to our login function, right, the user will have been successfully authenticated, right? And Passport is going to add the current user to a brand new object in the request, the user object. That user object was not there before we used Passport. Passport adds this additional object to the request, right, to let you know, hey, this is the currently logged in user. If you want to do something with that user, okay? What we're doing is something trivial. We're just sending it back to the client. We're just sending it back to the client saying, hey, this is the currently logged in user, which includes the user ID, includes maybe the username, right? And which the client might use to, maybe say hello or whatever, right? We're going to send that user ID back to the client. Make sense? All right? Yes. Right. If the authentication fails, we're going to write it in a minute inside of local strategy. We're going to configure it so that it will reject the user, like if the username and password doesn't match, and Passport is going to respond with an error, right? An unauthorized error back to the client, right? And the client will have to handle that error, right? Maybe putting popping up something on the window or showing some alert saying that sorry, that username and password, try again or something, right? Yes. I'm sorry. Yes, request that user will not be set. Yep. Yeah, it will not even make it into the login function. Right? It will notice that it's intercepting the login. Right? Here, typically all our requests that we've been looking so far have been like this. Right? the URL mapped to the function that handles it. See that? We're changing it and saying, no, I want somebody to intercept that first. Take a look at that and handle this request before I even get to the business logic. Right? So we're separating two things. Right? We're separating, say, there's a security side, the security layer, right? And after that, there was the business layer, right? All the logic that I want to handle once everything is dandy, everything is in steady state. Okay. All right. Okay. So let's put in here what local strategy is going to do when it gets intercepted. When it gets intercepted by the local strategy, it's going to expect a post, right? Which is already a post, right? In that post, the local strategy, part of the Passport API and interface, is that it's going to expect two items to be in that post, right? It's going to expect an attribute called username and an attribute called password. It has to be spelled out exactly like that, all lowercase, right? It's going to extract and parse the username and password from the body, right? And it will call the function. It will call the function that you provide here, right? As a mechanism to do the login, right? So it'll pass it here, password, right? These are local variables. These are local variables. They don't have to be called that way, but the post, right? The body needs to contain those two fields: the username and password spelled out, username, password in English, all lowercase. Make sense? All right. And then if it finds it, it will call the local strategy and pass the username and password that were parsed from the body. All right. So what are we going to do with that information? What we do, right, we're going to do just a normal query to the model, our model. Right? We're going to validate that username and password that came from the client. We're going to validate it against our databases. Okay? That's why it's called a local strategy. We are responsible locally to try to test the validity of this user against our own local database. Right? When we look at next week at Google and Facebook, right? We're not going to have their databases, right? They have their own databases, right? We're going to redirect the user to log in at Facebook, at Google, right? They're going to test the username and password against their own databases, right? And they're going to come back to us saying, yes, this person is validated or not, okay? So that's all we get from Google or Facebook, whether it's valid or not. Here, we are responsible to validate against our own database. Make sense? That's why it's called a local strategy. Like Passport doesn't know what the database is, right? Or what the schema is, or what the model is, right? It just provides the API, right? The layer, right? The interface to talk to the rest of the framework, right? So internally, we need the user model, and we just wrote this, right? Didn't we just write this? Let me make sure that we spelled it right in the user model. Oops. No, that's not what I meant. Copy. Fine. Yes, we spelled it right. Good. So it's going to use this user model. We're going to have to require the user model here. So var user model is going to be, let's go up one, down to models, down to user model. Oops, user model, there it is. So that means that we're going to have to export this user model. Let's export it here. Module.export, oops, equal user model. Also, we're going to add the all these functions, right, to that object. And find user by credentials. We're going to tie it there. Okay. So here we have user model, find user by credential. There it is. It's going to call that function. Notice that it's expecting a promise. You see that? All right. So we need to rewrite this to use promises. We could use the Q library, right, to sandwich this inside of a deferred, resolve reject, not abort, reject, right? Or we can use we can tell Mongoose, tell Mongoose to use the promise mechanism of Q. It says use Q's deferred, abort, reject, resolve mechanism, right? Instead of using the default one. And the way we could do that is to load Q. We say var Q require Q. And we can say, now that we load it, we can say Q.promise. So use Q's promise mechanism. And this we'll set it globally for all Mongoose communication backwards and forwards to the database, right? What this allows us to do is to go back to our simplified mechanism of just returning. This returns a promise that already contains the then and whatnot and all that, right? Instead of having to use a... But sometimes we need the granularity of deciding exactly when we want to reject or when we want to resolve, right? This one just says, I'm just going to pass it to you, and you're responsible for it, right? For rejecting and whatnot, okay? All right, so find user by credit. So let's do the same thing for create. Let's do the same thing for create. We're going to remove all this, and we're just going to say return. All right, I think we're done here with return the user model. We have the user model right here. We're going to say username, blah, blah, blah. We're going to, here we're passing an object, but here we're just receiving a just plain old strings, right? So let me change that a little bit. I don't need this object. Like that, okay. Then let's see, username. So presumably we're going to get a user object, hopefully. All right, so let's look at this for a second. Notice that the local strategy takes a third attribute here, a third parameter, done, right? This is a function, right, that is passed to us by the Passport infrastructure, right, the Passport library. It passes us the username and password, which is going to parse it out from the body, yes? And it also passes us a callback function that we're going to use to notify the Passport library whether we accept this user or not, right? Whether to reject or accept this user as a valid user, yes? Right? So you can call it whatever you want, right? A very common name for the callback function is done, right? And we're going to use it to notify Passport whether, yes, the user is good, or no, the user is no good, right? And also you can provide some meta information, right? Why this user is no good, right? Some error message such as, the password doesn't match, or the username doesn't match, or neither one matches, or whatever, right? You can pass in a message saying why did it fail, okay? But here, the second argument is either the actual user object that came from the database, right? Or something falsy. It could be 0, it could be false or empty string. Something that says it failed, right? This user is no good, right? If so, here I have the logic that if the user is empty or is null or whatever, but coming back from the database, we're going to reject it, right? And right there, Passport is going to immediately send back an unauthorized error back to the client, right? It will not even go to our login function. Yes, right? If instead we say and we pass a user object, we say done, right? Then it will continue to the login, to the next function, which is the login function. Yes. In our login function, we're just going to respond saying, yeah, here's a user who just logged in. Here's a user ID, here's our username, whatever we have in that user object. Make sense? Everybody good? Okay. One more thing. Like Steve Jobs used to say. We need to configure the fact that we are going to store things in cookies, right? Things are going to be stored in cookies. The user object is going to go back Sorry. Let me turn this off. The user object, right, is going to be sent back to the client not only as a JSON object, but it's going to be encoded in the cookie. Okay? It's going to be written right in the header, right, as a cookie, and the client is going to store that in their own cache. Yes? Right? So we need to decide what is it we want to put in the cookie. Right? We're going to put in the actual user object. It doesn't have to be the user object. It could be just enough for us to be able to reconstruct the user object. The user ID would be enough. Okay? And we're just going to put the entire user object in the cookie. All right? So it's going to at least contain the user ID, at least going to contain the username, right? Perhaps the first name, last name is going to be in there, right? So it's going to have some private information, right, for the user. So we want to make sure that that is encrypted, and we did that already, right? We configured the session to be encrypted, giving a secret, yes? But also we need to configure Passport on how, how to, we have to tell it what is it that we want to put in the cookie, and then we need to tell it that once it comes back from the cookie, how are we going to reconstruct the user object, right, from that cookie, right? We have to tell it, hey, there's a user ID in that object, right? Retrieve that, look it up in the database and see if that user still exists. Make sense? Right? So to do that, we configure serialization and deserialization of those objects from the cookie. All right, so let's copy that and let's configure Passport. We're going to say these two functions are going to be responsible for serializing and deserializing the user from the cookie. So we're going to copy that. I'm going to configure it down below. There it is. So here is determining what is it that we want to store in the cookie. What is it that we want to put in the session, right? We're given, as an argument, we're given the user object. We can decide that we only want to store the ID. That would be okay, right? But for convenient purposes, I'm going to store the entire object. And the way we do that is by saying done. Well, we call the callback function done, and we pass whatever we want to put in the session. The entire user object. We could put whatever we want, but I'm putting the entire user object. When it comes back from the client, and the cookie comes back from the client, and it sets up the session, it's going to pass us. It's going to call the deserialized function. It's going to give us a chance to look up what's in the cookie, what's in the session, right? And say, okay, how do you want to reconstruct the user, right, from the session, right? So it's going to pass us the user object, right, that it's grabbing from the cookie, and we're going to extract the user ID from that object, and we're going to retrieve the user again by looking it up in the database by ID, which we don't have. And then if we find the user, we're going to say, yep, that user does exist, still exists, hasn't been unregistered or anything. Otherwise, we're going to say, nope, that user does not exist anymore. Okay? Well, we don't have this function, so let's create that function in the user model right here. We say function find user by ID. Here's user ID, and that's going to be going to return user model dot find by ID user ID. Okay, and let's tie this in the user model. So user model dot find by user. There we go. All right, I think we're ready to play around with login. Okay, so that's all the server side setup. Okay, let's go back in the client and let's start generating some posts from the client. So let's go to public. Let's go to lectures, and let's create a directory here to play around with Passport, and let's create an index page in there. Index. And let's load Angular. So it's up a couple of places here. JS. We have Angular. There it is. Angular. Let's also load Bootstrap. Go up twice. CSS Bootstrap. This is a style sheet. All right. Let's see what else. Let's load our application, which we don't have yet. Source. We're going to put it in app.js. Right, and so in app.js, let's create a app.js here, and let's declare a an Angular module, Angular.module, and let's give it a name of Passport app. And right now it's not going to depend on anything. Let's see what else. Let's declare here. Let's declare here a controller. For now, we'll call it the login controller. Implement it. Oops. Implement it right here. Controller. Very good. Also, let's configure. Okay, let's do it like that. Let's keep it simple today. And let's declare here ng app as my passport app. There it is. Very good. Let's declare here a div. Oops. A div class. Let's have this a container. Container fluid. And let's say that this is h1. This is login. And a two input field. So input class form control. This will be an ng model. It will be user. So this will be user.username, right? And another one for password. So this will be password. And then a button that if we click it, we're going to call model.login, and we're going to pass the user object. Okay? And let's paint this to be a button and a button block. Block and be a primary. So it's blue. All right, so let's see, and we have to give it a controller for this, right? So this will be ng controller will be the login controller, and as model. All right, okay. Let's see. Let's run this. We'll need to load that service, right? We'll need to load that service from here. So let's see. Let's require the lectures, passport, services, and then in there we have user service, right? Let's load that in the background, and let's run this. Let's see. Let's see if this blows up. Okay, it didn't blow up yet. Let's log in to. Let's try to hit that login. So that's in lectures, passport. There we go. And I think we need we need something in the button. So we'll say that it is login. There we go. So we have the username here. Let's sniff the HTTP, see what the network communication says. So we say bogus. We say login. That didn't seem to work. Source. Did we load the? We have the. We have the app. We have the control. Oh, the control is not doing anything, right? So let's write that little controller. The controller is going to do what? It's going to be var model this, and model.login is going to be a function that is going to take the user object, right? And we want to do is do a post, right? We'll write this in the service a little later. So HTTP, I want to generate a post, yes. And the URL is, what's the URL? There's the URL, right? Right here. To do this login right here. There it is. And we're going to pass, what are we going to pass? We're going to pass the user object, which contains the username and password, right? And hopefully, this is going to come back with a response. And let's look at the response. Console log response. There it is. If it's successful. If it's not successful, it's going to come back with an error. We can do console.log the error. Okay? All right, so let's try that. Let's reload this. Oops. Uh-oh. Console. Oh, my goodness. Root scope. What did I do? Aborting. Bad, bad, bad. That's no good. XML, yeah, request. HTTP request. Ah! Let's see. What could it be? What could it be complaining about? We have app, module passport app, login controller, yada yada yada, login controller, model this, model.login function. What? ng click. Thank you. ng click. Okay. Yeah. Very good. Good catch there. Login controller as model. All right. Let's try this again. Localhost lectures. Passport. Inspect. Okay, it didn't go into some crazy. All right, so let's log in with something bogus. This gave an error. It says, okay, so notice it says unauthorized. See that? With a 4.1 unauthorized because QWE and EWR are not there. But if I say Alice, right, notice that it comes back with an OK. See that? Right? So we can use this mechanism so that if you get unauthorized, we could say something like, where are you? In the index, right? In here, we can say if it's an error, we can say model.error, right, equals error, right? And here we could say model dot message equal welcome, right? And in the index, we can say here perhaps some error message. We say div class alert, and we can say alert danger. We can display this. We says and give the error here, right? We can say model.error, right? And display this only if ng show only if we have a model error, right? Error. Or have here div class alert with a nice info. Okay, this is alert. And only show this if we have a message, right? And this says, and here's the message, model.message. Okay, so that if we log in and we have something bogus, and we do a login, right, we have an error message, unauthorized, sorry, whatever, try again, right? Or if we have something correct, it says Alice, we have welcome, right? We have a welcome. Now, let's see what comes back in the network, in the login. And notice that it comes back with the entire user object. See that? Even the password. Okay, we should remove that password from there before we send it back. So the login function sent back the user. So here you could say welcome error message, right? And then we can put in the response. Notice that it's in the preview. That's the object that comes back, the response, right? So we could say that model.user, right, is the response. Right, so we could display here a model.user. So if we log in as Alice, we can log in, and there we go. We have the information about Alice. Make sense? We display welcome Alice and whatnot. All right, so we'll continue this next time around. What we'd like to be able to do is log in, be able to go to the profile page, right, where the user has the information there. Also, we need to protect the profile page, right? Right now, we can just go into the profile page, right, without having to log in. So we need to protect the profile page because it'll have some private information. All right? Awesome. Thank you.